Glad you're back. This is part 4 of the Exam 1 review for Math 310. Now we're getting to our linear inequalities, which really most of y'all picked up on very well. So let's go ahead and graph this linear inequality. X plus y is less than -5. So we want to put it in slope-intercept form to graph it. And that means subtracting x from both sides. And we have y is less than -x minus 5. Okay, there's our equation. Now let's graph it. So we will have a green plane. And we will find 1, 2, 3, 4, 5. There's where that boundary line goes through the y-axis, but the boundary line is going to be dashed because our inequality is a less than. If it had been a less than or equal to, our boundary line would be solid. Our slope is going to be negative. It's going to run downhill from left to right, and it's going to be -1. So from this point here, we can use our slope to find another point. So let me draw some more little tick marks. So we can either go down 1 and to the right 1, or we can go up 1 and to the left 1, up 1 and to the left 1, and so on. So I'm going to go up 1 and to the left 1 and plot that point, up 1 and to the left 1, and I'm going to draw a dashed line 1, 2, 3, 4, 5, and that's going to be a point. Well, pretend that that's a straight line and my points are lined up and everything, but that's about what it would look like. And it has a negative slope of -1, and it goes through the y-axis at -5. It's a dashed line because of the inequality. Which side should we shade? Notice that we did not have to turn that inequality sign around. We didn't move y from the left to the right, and we didn't divide or multiply by a negative number, so we never had to mess with the direction of the inequality. This says that y is less than the line being -x minus 5, so that means we can confidently shade everything under the line because y is less than the line. But let's check that out. As you know, I like the test point 0, 0. So we're going to plug in, all right, this is the test point 0, 0. We're going to plug that in, 0. Actually, let's plug it into our original equation. So that means if we made a mistake moving from here to here, well, we'll catch it if we plug into our original equation. So x equals 0, y equals 0, that should be less than -5, or that should actually not be less than -5. So 0, this says 0 is less than -5. Well, that's a false statement. So that means 0, 0 is not a solution to this linear inequality. And since 0, 0 is in the area that is not shaded, then our graph is correct because it's not shading the parts that don't work, it's shading the parts that do work. So that's how you graph a linear inequality. Here's a case where we have a linear inequality that actually goes through the origin. Okay, we want our formula y is something mx plus b. So we're going to switch the -3y to the other side. That means when we move it, we have to switch the direction of the inequality. And now we're going to divide everything by -3 to get y by itself. And we get y. Now when we divide by a negative number, we switch it again. And we get -1/3 x. Okay, now here's where a lot of people will make a mistake. You'll graph this as if it were saying y is greater than or equal to -1/3. but it's not saying that. It's saying y is greater than or equal to negative 1/3 x. So when you see that x and y are both there, but there's no b, then you write in a b. Just write plus 0. And what that tells you is that your boundary line is going to cross the y-axis at 0 at that point there. And it's going to, let's draw some tick marks. It's going to have a negative slope. It's going to go down 1, 2, 3, 4, 5, down 1. Let me do this. You start from here, down 1 and over 1, 2, 3. So one of our points is going to be there. And you could go up 1 and over 3. So one of our points would be here. Whoops. Okay. So we're going to draw a blue line with that little slope. Only it's not dashed, it's solid. That is a solid, nice, neat line. Anyway, there it is. And so that's what our boundary line looks like. And y is going to either be on that line or it's going to be greater than that line. So that means our solution, our area being shaded, is above the line because y is greater than. Now we can't use our test point 0, 0 that I like so well because it's on the line. So let's use, how about 0, 1? Keep as many zeros as we can. And so this is the point 0, x equals 0, y equals 1. So we plug those in. We have 1 for y is greater than or equal to negative 1/3 times 0 plus 0. Well, anything times 0 is 0, and 0 plus 0 is 0. So this is telling us that 1 ought to be greater than or equal to 0, and 1 is greater than 0, so that is a true statement. That means 0, 1 is in our solution area, which is shaded, so we have graphed this correctly. Okay, is this relation a function or not? And give its domain and range. Remember that a relation is a set of ordered pairs. This is a set of 3 ordered pairs. The domain is the x values, and the x values are 5 and negative 3. So we can go ahead and give the domain is 5 and negative 3. No parentheses involved. 5 and negative 3 are not an ordered pair. They're x values, and the set of them goes in brackets. The range is going to be negative 2, 5, and 1. Okay, and to determine if it's a function, we want our x value, or our input, to go into our function box, and we want a dependent variable y to come out of it. And for every x value, it cannot produce, the same x value cannot produce 2 different y values. So if x is 5, y is negative 2. If x is negative 3, y is 5. And if x is 5, which we have here, then we expect that y is negative 2, but this tells us, no, y is 1. Well, that can be true in a relation, but it cannot be true in a function. This function will not work if we put 5 in and we have a possibility of getting negative 2 or a 1 out. So this is not a function. Okay, we have a straight line here, and as long as that line is not a vertical line, then we have a function. And one way we know this is the vertical line test. We can drop a vertical line anywhere here. That's not really vertical, but pretend it is. And it only crosses the line at one point. Each of those vertical lines only crosses at one point. So that means it is a function. And unless a line is horizontal or vertical, the domain of a straight line is going to be the interval running from negative infinity to infinity, and the range is going to be the same thing. And that is all there is to that problem. How about this problem? If you drop a vertical line, is it going to cross at more than one point? And yes, we can see clearly that it will. If we drop a red vertical line there, it crosses at 2 points. So that is not a function because it fails the vertical line test. But it still has a domain. It's a relation and it has a domain. And the domain is x. Where does x go? Well, x can go to negative infinity, right? Because we see that the graph is going to extend. And so x will show up all the way over here. So it's going to go from negative infinity. And then on the right, it's not going to go past x equals... Boy, that's the wrong point. They drew that wrong. So let me fix that. That should be x equals 4, y equals 2. Okay, so x equals 4 is the highest number of x that we can get, and it is included in it. It's so we use a bracket to show that 4 is included. Now what about the range? The range is the y values, and if this graph extends like this and this, you can see that if you just go out to infinity, y can go all the way up to infinity or all the way down to infinity. So the range is negative infinity to infinity. It doesn't have an abrupt stop point like that x does. Here we're given a function. We're actually given two functions. F of x is negative 2x squared plus 3x minus 4. G of x is 4x minus 1. And it tells us find g of r. Well, first of all, let's clear things up a little bit. That means we don't need f of x at all because f of x isn't even playing a part in here. So let's just get rid of that. We need g of x, and we need to find, what about when x equals r? That's what it means when we say find g of r. And so we write g of r, and then everywhere in this function that we see an x, we replace it with an r. So we just say 4r minus 1. Boom, we're done. Here are the same two functions, but now we're supposed to find g of negative 5t minus 2. Okay, it doesn't tell us to find f of anything, so we can go ahead and get rid of that f. We don't need it. But for g of negative 5t plus 2, you may want to take the step to say x is going to equal negative 5t plus 2. Put it in parentheses. So that means when you look here, then every place you see an x, you replace it with negative 5t plus 2. So g of negative 5t plus 2 equals, and I'm going to write 4, and then I'm going to plug in my negative 5t plus 2 for x minus 1. So then, okay, let's just scratch that out so it didn't get in our way. So we have equals negative 4, and then we distribute that 4, and we get negative 20t plus 8 minus 1 equals negative 20t plus 7. So g of negative 5t plus 2 equals negative 20t plus 7. So we're not really that familiar with the nomenclature of all this, and it can be a little confusing, but the actual problem is very simple. You take whatever this is, since it's g, you don't use this one, you use this one, and you say instead of g of x, which is 4x times something, we want g of negative 5t plus 2, which is 4 times negative 5t plus 2 minus 1. And then you simplify it. In this problem, we're given the same functions and we're said to find f of negative 5. So we're going to use the f function, not the g function. Let's go ahead and get rid of that one. Only instead of f of x, we're going to have f of negative 5. So wherever we see x, we're going to put negative 5. Okay, so let's rewrite it. F of negative 5 equals negative 2, and then use parentheses around it to be careful. Negative 5, because x is negative 5 squared plus 3 times negative 5 minus 4. So now we just have to simplify this. Okay, first keep that minus 2 alone because you first do exponents. And negative 5 squared is the same thing as negative 5 times negative 5. And negative 5 times negative 5 is 25. Positive 25, because a negative times a negative is a positive. Okay, plus 3 times negative 5 is negative 15 minus 4. Okay, negative 2 times positive 25 is negative 50 plus negative 15 minus 4. We can even call that plus minus 4 if we want to. Okay, so that's going to be negative 50 plus negative 15, two negative numbers. The absolute values add and you get 65. And since they're both negatives, your answer is going to be negative plus negative 4. So that's going to be negative 69. So what that tells you is that f of negative 5 is negative 69. In this problem, we're to graph a function, but don't let the g of x fool you. You don't have to mess around with g of x. All you're going to do is graph it, so you can just change it right away to y. Y equals negative 1/4 x plus 1. That is exactly the same meaning as g of x equals negative 1/4 x plus 1. Well, by now we're pretty familiar with how to graph that. We have it in y equals mx plus b form. So we find b on the y-axis, 1. We look at our slope and say it's a negative slope, so it's going to run downhill, and it's 1/4. So we're going to go down 1 and over 4. So let's plot that. Down 1 and 1, 2, 3, 4. There's that. Or we could go from the original point up 1 and to the left 4. So we would plot this point. And then we just graph that line. And there you have it. In this problem, you're to graph the line passing through the point and the slope that are given. And the point is 4, negative 3, and the slope is undefined. An undefined slope means the line is vertical, and it goes through the point x equals 4, y equals negative 3. We can go ahead and graph that right there. And the line is vertical, so we just draw the line along the axis where x equals 4. And that is the end of the Exam 1 review for Math 310. What I recommend you do now is, if this is your first attempt, take a few practice exams. They need to be more than one because one is not representative of the exam. Take a few practice exams and then use the study plan to practice those problems you're still weak on. If this is your second attempt, go ahead and use the study plan, which will create problems similar to those you missed on the test. Good luck.